Hello, Professor. Today I'm looking at the wage inequality in the U.S. using quantitative regression. The big question is, do things like education and gender affect low wage workers and the high wage workers in the same way? Here is the roadmap, the outline. I will cover the motivation and the theory first, then the data, and spend most of the time on methodology and the results. Why quantile regression we choose? Because the ordinary OLS only give us the average effect, and the averages can be misleading. Education might matter a lot more for higher earners than the low wage workers, so the OLS cannot show us this situation. There are three theories guiding our study. Human capital theory says the education boosts the wages, but doesn't say the boost is equal for everyone. Segmentation theory says the good job and bad job have different payoff structures, and the glass ceiling idea says women face bigger barriers than the higher they go. The quantile regression lets us test all the three theories. The data comes from the U.S. Census, about 30,000 people. We look at log wages as the dependent variable. On the right side, we have education, experience, gender, and hours worked. A pretty standard wage equation setup. And we just need to quick look at the descriptive state, the descriptive outputs. So every data is okay, everything is okay. So we can just jump to the next step. Okay, this is the wage distribution. Looks like the normal with a slightly right tail, pretty typical for wage data after taking logs. So this shape works well for our following analysis. Oh, and this is another figure. This figure, we can see how wages related to our k variables. As we can see, more education clearly means higher wages. Age shows an inverted U shape, and the wages go up early in your career, then flatten out, and there is a visible gap between men and women. These are the same relationships broken out individually. Education goes up, wages go up, and the age has that hump shape. So, and the gender plot confirms men earn more on average. All of this motivates our model setup. Okay, this is our OLS model, a standard Mincer wage equation. As we can see, the education and experience should be positive, and the squared experience term should be negative to capture that hump shape. And the male dummy should be positive. The table on the right shows that shows what we expect and why. Now the quantile regression part. Instead of fitting the mean, we fit different points of the distribution. The K is that coefficients can change at each quantile. So we can see if education matters more at the top or the bottom. We pick 5 quantiles from the 10% to 90%. and also plot the full range for the figures. Okay, for diagnosis, we do four things. Firstly, we checked if the error variance is constant. And secondly, we use bootstrap method for the more reliable results. And finally, we run the word test to formally check if coefficients really are different across quantiles. And after that, we report the R-squared value to see how well the model fits at each quantile. Okay, let's see the OLS baseline firstly. Everything is significant and has the expected sign, the expected result. One more year of education means about 5% higher wages, and the men earn about 8% more, and the R square value is 0.47. It's not bad, but there are just averages. So the real question is, are these the same everywhere in the distribution? Okay, now this is a K-table, and look at how different the numbers are across quantiles. The education return goes from about 3% at the bottom to the 6% at the 75th. So this value, we can see it doubles. So the gender gap is even wider, from 1.8% at the bottom to the 14.3% near the top. The OLS gives us one number that hides all of this. And this is probably the most important slide. And we can see each panel shows how a coefficient changes across the whole distribution. The shaded area is the confidence interval, and the dashed line is the OLS estimate. You can see that most coefficients move a lot. They are clearly not constant. And let's zoom in the education. The return roughly doubles from bottom to the top. In plain terms, if you are already a higher if you are already a high wage worker, an extra year of school helps you even more. So education actually widens the inequality, not narrows it. The gender story is even more striking. At the bottom, the gap is tiny, less than 2%, but at the 75th percentile, it jumps to over 14%. That is 7 times bigger. So this is really fits the glass ceiling idea, which means the higher up you go, the harder it gets for women. And the OLS just tells us the average 8%, which missed the whole picture. The experience also varies across quantiles, but less dramatically. High wage workers see a steeper rise early in their career, but it also fades faster. Basically, career progression matters more in higher paying jobs. On the left, both tests reject constant variance, so using quantile regression is well justified. On the right, the word tests are all highly significant, which means those differences across quantiles we just saw are real, not random noise. So the F statistics are very large. So this is a model fit varies by quantile. The best fit is at the 75th percentile, about 34%. The weakest is at the 90th, meaning at the very top there are other things we are not capturing, like the occupation or connections. And we also did some robustness checks using robust standard errors doesn't change anything. Adding race as a control barely moves the numbers, so the main findings are quite stable. There are three main takeaways. The first one is the education helps high earners more. It widens the gap. The second one is that the gender gap is bigger at the top level because of the classic glass ceiling theory. The third one is that the OLS completely missed the ordinary OLS completely missed these patterns. That is why quantile regression is better. And what does this mean for policy? Just expanding education will not fix inequality. It might even make it worse. So for gender inequality, we need to tackle barriers at the top, not just hire more women at the entry level. And wage policy needs to work on both ends of the distribution. Of course, a few limitations to be honest about this is because in our research this is a cross sectional data, so we cannot say anything is casual. We are also missing some important controls like occupation and industry. So I think future work should use the panel data and look at how gender and race interact. To wrap up, quantile regression shows that things OLS cannot. Education widen the gap, the glass ceiling is real, and one size fits all policies won't work. You need to target specific parts of the distribution. Okay, thanks for your listening. I'm very happy to do this